Page 342, this is question 9, a crazy question. You've got absolutely nothing to go on whatsoever, so you better draw a picture. Right, we've got here a semicircular piece of card. Right, let's draw it. This is a semicircle piece of card. And that's me drawing it freehand. That's the centre of the entire circle. And I'm told it's got a radius of r. So there's a radius of r there. There's another radius of capital R there as well. Now I'm going to fold this. Imagine this little part here, this radius, being folded so that it touches this part. I will get a cone that looks a little bit like that. And this is like the circular part of the cone. So imagine it's a see-through cone made out of plastic. And if that side touches that side, I should end up with the slanted side of the cone being the same length as the radius of the cone. If you can't see it, cut out a large semicircle, fold it in half and join these two ends so this part reaches that part there, and you'll make a lovely cone. So I know that therefore the slanted length, the long side if you like, of this cone has the same length as the radius of my semicircular piece of card. I'm told it has a height of h, so let's just get inside and draw a dotted line to the centre of the floor, and that's called h, the height h. And if I join the centre of the circle at the base to the circumference, I reunite myself to this original radius that came from this semicircular piece of card. So I've got an h and r, and I've got an unknown radius at the bottom, which I'm going to call x, say. Now as you can see, we've got to somehow create an equation involving h and big R and this mystery x. Now the original proof does not have a mystery x or mystery y or any other letter in it. It's got this horrible 2 and the square root of 3 floating around, which is awful. So we've got to get there somehow. So therefore the x has got to be eliminated. We can't have x. It will be far too easy to say h squared plus x squared equals r squared. It's totally true. There's a right angled triangle there. There's the height. There's the base. There's the two smaller sides. And there's the hypotenuse r. So that's not good enough, not for A star. This is beyond A star. It's crazy. Right, I've got to prove that the height is related to the radius using these silly little numbers. Now, if you can imagine, if you can't imagine, then go away and cut it out. This semicircle, this semicircular arc, when folded round, will create the entire circumference of this smaller circle here. Now this smaller circle, of course, is the base of the cone. Now you know that the circumference of the cone is 2 times pi times little r. Now of course the little r is in fact, I've already called it x, so let's just call it x anyway for completeness. So circumference equals 2 pi times little x for radius. Now if you can see that this small circular part of the base of the cone is identical to the length of this arc, that is to say the perimeter of the semicircle outside here, not including the two radiuses, just this part here alone, the length of that half circle, that arc, then I can get an equation for the length of that part just there. So look, put an arrow to that. This part is based upon c equals 2 times pi times r. But of course it's not an entire circle, it's only half a circle. Therefore arc length equals 2 pi r. Of course I'm based upon half a circle, aren't I? Alright, so it's not a whole circle, it's only half a circle because it's a semicircle. So 2 times pi times big R divided by 2. What am I left with? I'm left with pi times big R. So this length, without having any numbers at all involved, I know it will be r times whatever, pi times r, that's it. So this pi r is exactly the same as my c equals 2 pi x for the base of the cone. So let me substitute this 2 pi r into my 2 pi x. Alright, so let's just change colour, it's getting serious. So I've got 2 times pi times x equals pi times big R. Look, the pi's cancelled straight away, and I know that therefore that x equals r divided by 2. That's important. Look, so 2x equals r, x equals r divided by 2. Now I've eliminated my x because instead of having an x there, I can now call this r over 2, or half an r. Alright, so I've got an h, an r over 2, and an r. Now I can create an equation involving my height h, my hypotenuse big radius, and my little radius in the cone, which happens to be r over 2. So let's do Pythagoras then. And we do it right here. So Pythagoras, so it's that square plus that square makes the big one squared. Here we go. So h squared plus big R over 2 squared equals big R squared. Okay? Small side squared plus small side squared makes the big side, big R squared. Tidying this up a little bit, I've got h squared plus r squared over 4 equals r squared. Let's get the r squared together. Look carefully. If I take my r squared over 4 next door and subtract, I've got a whole r squared take away a quarter of an r squared. So what does that give me? It gives me 3/4 of a radius squared. Is that fair enough? Now I'm going to need to work somewhere else here. I don't know, let's just go over to here. So I've got, this is right up here, I've got h squared equals 3r squared over 4. So in other words, 3/4 of a big radius squared. Remember, this big R comes from here originally. Take the 4 over to the other side, so I don't have no horrible little divisions to deal with. So 4h squared equals 3r squared. Okay, so I want to get h on its own. So square rooting everything, square root of 4 times the square root of h squared equals the square root of 3 times the square root of r squared. Well, the square root of 4 is 2. The square root of h squared, plain h. The square root of 3 is a third, it's just called root 3. And the square root of r squared is simply big R. Alright, so what do I got? Get h on its own. H equals the square root of 3 times r, then divide by 2. What does it say? It's exactly the same as that, isn't it? Therefore h equals r divided by 2, in other words half an r, multiplied by the square root of 3. They're exactly the same. Now that is mathematics. That is a complete pain, and it's been proven. I had to create an x or some alternative symbol for the new radius of the base of the cone, and of course it had to be related to the radius here because I made the cone from this semicircle of radius big R. It had to happen, and my x had to be eliminated because there's no other letter in the proof other than the height and the radius of the original semicircular piece of card. And that, friends, is how you rock and roll. That is a monster, and that is definitely worth a star, and maybe another one, and maybe a few more. Alright? Very tricky. I'm not going to do any more of those, so I'm going to stop now, maybe have a cup of tea, and probably have a little snooze as well.